All right. So, as mentioned, we're Dozer AI, and we do continuous AI monitoring for construction safety equipment. I'm going to be popping back and forth, so I swear I'll do the in and out, but this is going to be a bit of an Elvis show, so a lot of movement. All right. So, why is this a necessary thing? All right. So we have a major problem, which is heavy equipment. Construction heavy equipment has many blind spots. Even trained operators are hitting people all of the time, all of the time. And the biggest problem that we have here is that while automotive equipment, automotive safety awareness equipment can survive its environment, being on the roads and being outside parked, the situational awareness AI hardware that we have today, the stuff that we take for granted in Tesla vehicles and others like it, cannot survive in construction environments. So the result of that is pretty dire. Full screen. So as you can see, they can't see behind themselves because that's a normal blind spot. Operating under normal conditions with a spotter, even with the person directly in front of a machine, they cannot see them. And so a simple mistake, I didn't see that person, can end up with a person buried under 2 tons of dirt under normal operating conditions. So this is happening all of the time in the construction industry. This is causing an insane amount of loss of life, damage, lost days of productivity, as we can see. Scroll back one. And then if you can full screen me. All right, there we are. So these normal operating conditions result in 75 million days of lost productivity on job sites around the United States, just in the United States, in a single year. We're also talking about billions of dollars in line strike damage, people hitting things that they otherwise should see, otherwise know are there, but for the fact that they don't have that situational awareness technology. We're talking about non-fatal injuries in the hundreds of billions of dollars of costs for non-fatal injuries alone. That's just the loaded cost for those. And then, of course, the fatalities. It's insane to say, but actually it's cheaper and better for the construction companies if somebody is hit and killed because it is cheaper and it results in less days of lost work. So these are insane and staggering metrics to look at for a problem as simple as we can't see what's going on around us on equipment we are using everywhere in the world every single day to do one of the most common things we do, which is build infrastructure. And of course, contact with heavy equipment is the number one cause of that $167 billion a year of damages. So, what is a possible solution for this? Well, obviously, we need situational awareness enhancing technology, and Dozer has brought that to bear. So, we're going to go ahead and show you a video of what we're doing. So our system can actually identify people in real time, multiple targets moving around a piece of equipment and the body lines of the vehicle, including people that are partially or fully occluded by that equipment, plus other pieces of equipment in the environment, different parts of that equipment, and being able to track. These are very dynamic pieces of machinery and have many different shapes and uses. And we're able to track all of these different things all at the same time with a high level of confidence, including targets like traffic moving around your people, the equipment itself, things like cones, and people that are wearing safety equipment, people that are not wearing safety equipment, and being able to identify the difference between a person who is safe and a person who is unsafe in the same situation, to give this information to the operator in real time, even when the person is completely occluded. So what is it about Dozer that is actually transformational here, right? We're talking about cameras, right? We've got lots of cameras. There shouldn't be anything about this that is transformational. But the issue is that the hardware does not survive. The stuff that we have today is not designed, IP65, 67, those things are not designed to be out in the sun in Arizona all summer, operating constantly, getting hit by rocks at speeds comparable to bullets. Then going into extremely cold environments, Minnesota, where it's minus 40 degrees Fahrenheit or Celsius, it's the same temperature. So we're talking about something that can cause death in humans in minutes. And that's the environment that these pieces of equipment are operating in every day. So what's the solution? Mil spec. You need mil spec hardware for the coming age of AI to be able to bring AI technologies of any kind into these kinds of environments, which are all of the environments everywhere on Earth for all of time, for all of the rest of human history. How do we accomplish that? We need stereoscopic cameras. We need to be able to do SLAM mapping, depth mapping. Those are the systems that you saw in play in the previous video, where you're able to identify proximity between objects that are also dynamic and moving in the environment, vehicles, people, all of those things, be able to classify all of those things. You need to have a base station computer that can also survive in those environments, because a lot of those pieces of equipment don't actually have air conditioned or heated cabins. So we're talking about people that are completely exposed to those same elements, which means there's not a place to put a nice, comfortable NVIDIA GPU that can take care of all of this stuff. You actually need an edge compute unit that can process all of this data in real time and then provide that to the operator through the in-cabin alerting system, so that they know when they're going to run into something or someone. And then, of course, we want to make sure that not just the operators, but also the site supervisors, everybody that's involved in this project, is aware of everything that's going on at all times. So that for that, we have a 360-degree camera that's streaming from every single one of the different pieces of equipment. So not only does the operator know everything that's going on around them all of the time, but also the site supervisors know everything that's going on around all of their pieces of equipment everywhere that they are, instead of having to drive to multiple different job sites just to be able to monitor one piece of equipment. So we've already brought this to market. We have people that are paying for it. Local contractors buying these things up. They're introducing us to other contractors. Basically, the market is pulling us in this direction. We're not trying to sell this stuff. We are not marketing or advertising. We just launched our website to actually tell people about what we're doing. This is something that they're telling us that they've needed for a very long time. They're telling us that they want to bring this to market, and we're getting all the way up to publicly traded national contractors with over 10,000 units of equipment alone. And this is the reason why they care, because in the end, they know these numbers better than anybody. We're getting calls from contractors that have killed people or that have had massive injuries that have caused tons of damage and a lot of disruption in their markets. So we're looking at, on average, 1 in 400 construction workers, 1 in 400 will be injured by equipment every single year, right? The loaded cost of all of those injuries, as we remember, was $167 billion in a single year, which means that per injury, you're looking at $2.1 million of cost. And not all of that is insurable. So sometimes the contractor is just losing out on hundreds of thousands of dollars, plus the cost of retraining. And those workers, they're not going back to work. Each one of those workers that get hit, they're out for an average of 930 days. 930 days is basically, you need new employees, and you're cycling through them all of the time. And again, this is the normal operating market. This is like across every different kind of contract, from the safest one that's got multiple safety directors and an entire safety team, down to the mom and pop shop that's got 4 or 5 guys running around with a Bobcat. And another major reason for this is that OSHA, a quasi-governmental agency, does want you to have at least one spotter working persistently with every single piece of equipment that you have operating at any given time. That is specifically to stop people from running into people and objects, right? But that's expensive. That's $45,000 a year at very low, very conservative labor rates. So 45 grand a year plus a supervisor to actually oversee how is that equipment operating, and is it doing what it needs to do, where it needs to do it. So you're talking about over $60,000 per piece of equipment if you're following the OSHA requirements and best practices. And this is just another example of like one piece of equipment. This is actually one of the most popular pieces of equipment in the United States, right? It's called a telehandler. This allows you to take materials, pick it up with basically a forklift, and then elevate it up to a second floor level. So pretty much any construction project that is 2 stories or higher, or has a steep grade, or has to load and unload materials from the back of a truck, may or will have one of these units. So this is the most rented piece of equipment and the most purchased piece of equipment in the United States. We talked to the manufacturer, one of the largest ones in the country, actually in the world, of these units. And they were saying, we absolutely need these on every single one of our units. Like the moment that you're ready for these, we're ready to put this on our 30,000 units per year of new telehandlers. And the reason why is because they're basically flying blind all of the time. If you're lifting a load, you can't see past that load. So, and that's the direction of travel that you're moving in. So you're moving potentially 20 tons of equipment forward completely blind in the direction of travel. Then when you're actually operating the equipment at the ground level, all of this area is blind, right? Pretty much every direction that you're looking at is completely blind. And then this is the normal design for this equipment. The entire right side is completely occluded. You cannot see 180 degrees on the entire right side of the vehicle. And that's the norm. So the reason why this is such a massive opportunity and is ultimately market viable is that, these pieces of equipment that people are buying are largely the same as they were 20, 30 years ago. And they're already spending 150, 200,000 or more dollars per piece of equipment to get basically the same stuff that they've ever had. So if we're looking at just serving the new equipment market each year and taking a very, very small chunk of the 333,000 units of equipment sold here, we just want to get 10,000, then we're looking at potentially $210 million worth of hardware revenue alone at prices that we've already validated with our customers. We've told them what this is going to cost. They have no problems with that. It doesn't even blip the conversation. But if we start scaling up, as we move forward, we can actually cut that hardware cost down, get that down to about $6,000 a year or possibly even less, and then focus on delivering this as basically safety as a service. So we can make your stuff more safe. We can add more features over time and continue improving your hardware rather than it just being what it is and getting progressively worse, and being able to list that at a pretty healthy $500 a month per machine, which makes it a $600 million a year revenue stream. So at fairly conservative numbers, you're able to get to a massive scale. And remember, this is a retrofit. This does not need to go in new equipment. This can go on any piece of equipment that's already out there in the field today. It's completely agnostic. So you're not buying new equipment. You're just putting on this unit, and suddenly you've got the most advanced safety technology in the market today, as opposed to having to spend $150,000 just to get the equipment to then install this on top of. So this is not the only market that needs this kind of technology. As you can see, all of these other areas, warehousing, transport, and agriculture, are just as dangerous as the construction market. And they're served by the same kind of hardware. If you're able to survive the environment outside in the field, getting hit with rocks, in the blistering heat, in the freezing cold, then you can serve every other one of these markets, which are, less or the same amount of hostility. And of course, once you are a mil standard product, it's a very obvious jump to military and government. So we're looking at potentially a $5 trillion market outside of our core market that we have to serve that has the exact same issues, extraordinary safety concerns that have absolutely no path to commercial viability because nobody is building this stuff at a commercially viable price. So just briefly going through this, the reason why we know we can do it is because we already have. Multiple members of this team have already built safety products to enhance situational awareness for motorcycle riding, which is another environment that goes from extreme heat to extreme cold. It had to do edge-based computing, contextual computing. It had to be able to survive and be a real-time safety monitoring system. So we cannot have any lag between the safety awareness system and your own awareness. On top of that, we were designing for human factors to make sure that it actually leveraged whatever biology you have to increase your safety, irrespective of if you have night blindness or poor vision or any other sort of physical ailment. It made up for those things. And that's exactly what we intend to do here. So just highlighting a few people, Alan Gear, our CEO, over here is kind of the software lead for everything. He has been building multiple different software products to scale up to the largest possible sizes. So we're talking about quasi Facebook scale, we are not going to have issues with our software not being able to keep up with the demand. Andrew is right now, he's our CTO over here. He's built, what is it? Enterprise security systems. He's built the transportation safety systems. He builds robotics with Amazon Lab 126, and he's kind of the go-to guy for all of those products out there. Likewise, myself, I worked with in transportation safety. After that, I worked at the IRS Office of Chief Counsel, so I've done cryptocurrency, bankruptcy related audits, so I can deal with a broad array of complex legal issues and be able to understand those things and translate those very easily to our entire engineering team. Who, as you can see over here, we're building out a group that can build these models for every single one of the different environments, and we know that we can make the hardware work. Last person I'll call out specifically is Art. Right now, Art is building enclosures specifically for aerospace. So he has extensive experience making sure that products get to mil spec and beyond mil spec, because as we know, aviation, like rockets, are one of the toughest markets to work in. Not only that, but we also have a very strong group of advisors. So in terms of being able to hit commercialization, we already have a very powerful group here. Sia, who's a VP of Sales, Mergers, and Acquisitions Integration. It means he knows how to identify the groups of people that are interested in acquiring your technologies and making sure that the acquisitions are actually successful after they're integrated into a very large organization like Siemens. Then, of course, we've got Jeff Smith and Gurdeep Sidhu. They both have done finance and business development for multiple different companies you have definitely heard of. And another person worth calling out is Brian Mello. So he is a VP of Engagement and Regulatory Affairs at one of the largest nonprofit organizations specifically focused on construction safety in the state of California. He is getting us introductions to pretty much every one of these groups. He's giving us constant feedback about the market's interest in getting this product as quickly as possible. So that's where a lot of that organic pull is coming from. We don't have to go find the customers, they find us. So what do we need at this point? The plan is we want to build those cameras, right? The cameras are the thing that fail the most. It's the thing that should be commoditized already. But we've been scouring the entire earth, talking to every vendor that we could possibly come up with. And whatever cameras that you can find, they're not going to survive the actual environments that we're being asked to pilot in. So we want to go build that modular camera that we can use for both the stereoscopic and 360 camera systems. And then we're going to use that camera to expand our pilots to just basically show more construction companies, more companies that are in these various environments, that we have a system that works right now, can be deployed in the field right now, and we can make their environments much safer than they are today with almost no effort on their part. So what do we need to do that? About $1 million. Not a whole hell of a lot, especially when you're talking about hardware. Usually it's tens of millions, but we can do quite a lot with not very much. Because ultimately we've done this stuff before. We've already sourced all of our vendors. We know how we're going to get it built. We've already worked with all of our partners in the past, and we've modeled this stuff out extensively. The offer for that $1 million is a $15 million cap at a 20% discount. And that's us.
Hi, this is Alfred again. Well, nice presentation. So what is the ask? Because what is the purpose that you're sharing this? Are you looking for users, investment? I'm not sure. Sorry.
Yep. At this point, we're looking for about $1 million of investment. This is the first capital in because we bootstrapped to the point where we have a functional unit with us in the room. And then we also have customers that have paid us for units that are currently in the field and they are working with right now. So at this point, we couldn't service more customers without spending an inordinate amount of money on hardware failures, because the existing hardware that we can use, the cameras specifically, just have a massively high failure rate under even like ideal California conditions. Because just when you look at the kinds of stuff that can actually do AI SLAM mapping, it's either extremely expensive to get something that has those the enclosures that can survive and the electronics inside that can survive those environments, or you buy something that's more commercially rated for like inside robotics or warehousing, IP65, 67 rated, and it fails every couple of days.
I think it was due to the camera chip
Well, thank you. I might miss out one very important slide just now. What is your pre-money valuation right now?
All right, sorry, I'll address one and then the other. So talking about the hard. No, I'll address both. I just wanted to get because she started and then the other one started. Okay, so addressing the hardware failures, the question was, what is the cause, the root cause of the hardware failures? Is it the chips or is it the enclosures? It's a combination, and this is really the tricky part of the problem. Because when you start talking about chipsets, let's say you take your iPhone, right, which is a probably one of the most heavily engineered products of all time, and you set it on your dashboard, right? And then you're running, let's say, just GPS navigation. If you run GPS navigation with the thing sitting in the sun for 30 minutes, it will overheat and shut off. And so that's considered normal. That's considered the normal operating temperatures, and that is a extremely heavily engineered product. When you start doing that with even GoPros, right, they can operate for a certain amount of time, but they're not designed to sit outside for multiple days, not being serviced, not being handled, not being warmed back up or cooled off. They're designed to operate under those conditions for a very short period of time. So it can be the chips. Sometimes it is the chips overheating and just being outside of operating ranges. That does happen. But sometimes it's as simple as you build an enclosure and the air outside or the sun heats up the enclosure, it expands, right? Especially around the edges. And not every one of those materials expands at the same rate. So all of a sudden you have places where water can get in. Water goes inside, then the air cools off. Then in the morning when it heats back up, now all of your lenses for your cameras are full of moisture, and then you don't have proper inferencing. And when you look at even Tesla's system, because we were just talking about why can't you use automotive, Tesla's system does not work when there's even a light mist, and especially when it is a light mist as opposed to a strong like torrential downpour. When there is coverage over those cameras, they don't work and they shut that system off. We don't have the luxury of being able to just shut the system off and say it's your job, it's your responsibility now. That's how people die.
The reason I ask this question is I have worked on two systems similar. One is I think I told you last time. One is NEPS compliance. NEPS stands for Network Equipment Building Standards. They are for telco systems, and for us to provide a NEPS compliance server, we need to like 195 degrees Celsius, and then under like on minus 20 degree. Anyway, it's a very wide range. So I do not know from temperature wise whether it's comparable with the MIL standards or not. But I gained from that experience is that a normal server would not be able to withstand that extreme harsh environment. So I know that you have to really design comprehensively, not just a chip, because we deliver a server. So fortunately, at Sun Microsystem, we had the NEPS compliant. We built the Netra NEPS compliant server to satisfy that rigorous requirements. So that is not a small effort at all. So if you ask for 1 million to get that, if it's a MIL standards similar to NEPS standards, that's too little.
It's much higher actually. But sorry, there was another question that was asked about what the pre-money valuation is. As we mentioned in the deck, it was a $15 million cap. We anticipate that the valuation is significantly higher, but ultimately we were pegging that to what is the absolute dead standard, like median for hardware valuations right now. That is from multiple data sets from multiple law firms, plus Carto, which is currently the largest provider of cap table management and tracks the most rounds out there. So this is like absolute median. Really, we've accomplished a lot more with no capital than $15 million reflects. But again, we want to heavily incentivize people that are that understand hardware, are savvy to this, and are not just looking to make an investment into a GPT wrapped clone that's going to run entirely on software, because this is a real problem. We hear it all the time that you don't need to build hardware in order to solve the problem, but you just hit the nail on the head, which is it is extremely difficult to operate in extreme temperatures, and everyone's just taking it for granted that somebody else is doing it, but nobody is. Now, going back to your question specifically about temperature, it's not just temperature, because MIL standard is not about heating something up or cooling it down in a vacuum. Right, that's a very easy thing to do relative to heating something up, then vibrating it, like putting it in a paint shaker. and actually having it vibrate at multiple different frequencies, because frequencies of different kinds can make things fail. So you need to understand what kinds of frequencies you're dealing with when you're operating directly around a diesel engine. And a diesel engine is going to vibrate at a totally different frequency than, let's say, a server that might have some sort of motion in it from whatever else. So it's not as simple as being able to say something else has been built and we can just leverage that chip or technology or whatever. It's going to be a combination of different factors. And that's, again, why this particular team is so well suited to do this, is that we've already done it. We've already had to build this stuff with whatever was commercially available in terms of chipsets. So we're not building new chipsets, and we're not going to build new chipsets. We're not going to build a new camera sensor. We're not building new lenses. We're not building anything that we don't have to build. It's just laser focused on how do we get something out there that is as cheap as possible, that hits that standard, so that we can put these things everywhere and never have to talk about hardware again. Because again, the hard focus of this company is building that software and getting it everywhere. There is no reason that collisions with objects should be happening anymore, but for the fact that there's only a handful of companies out there that are building anything related to collision avoidance. And if they are building it, they're taking different approaches for a whole bunch of different things. And they also require you to use a very specific kind of hardware. We can't do that. We have to focus on trying to get this stuff onto as many things as we possibly can.
So in other words, there's a famous saying that if you get the problem nailed specifically, then you have solutions half done. So it sounds like you get that piece, you understand exactly problem space, but where you need help is you need a more optimization so that you can experiment toward a optimal solution for that specific environment.
So we know what the environment is. That's the major advantage. Mil standard is clear. And we know how those pieces of equipment, specifically our mil standard spec, because not all mil spec is the same, but we know what our standard is and we know what it's used on. So we don't need help identifying the spec. We don't need the help to identify how to build to that spec, because we have the people that have already done those things. It's literally just, we need to bring in the capital to go build that thing. And that's why, like, we're looking forward to the people saying $1 million is not enough. And we're like, cool, how about we'll go prove it. We'll just go prove it. We'll get past the point where this is going to be something that can be produced and we can show it in these working environments. And once we're there, then it's a question of what else potentially could fail. But in the end, we are still bringing one of the few, if the only, computer vision systems that can actually be deployed anywhere without significant risk of failure.
So with the existing chip, you would be able to do that?
Yes.
I see.